Hi everyone and welcome back to my channel. For those of you that are new here, my name is Ellie and I'm the founder of Code of the Future. And today we are going to be continuing with the Rust course. So as usual, I'm going to put my glasses on and I'll move you onto the screen. Okay, so in the previous section we looked at printing and formatting, which is in this tutorial 4, and that's section 4, I guess, of this series. And we looked at, printing and formatting, how you go about formatting your code, how you can actually get Rust to format your code for you, as well as some important things like this here, where you can't just simply print a number out. That's not how Rust works. You have to do this specific command here. Okay, so that was what we did in the previous section. Now I have created a new new project called Tutorial 5. So I have created a new project called Tutorial 5, and this is the file where we will be coding in. Now today we are going to be looking at variables. Now some of you that have maybe done coding before, you'll understand what variables are, but they're very important in Rust. I mean, it's very important to first of all make a video on it, explain them, because they are quite different to other programming languages. They're a little bit different to Python, and I wanted to introduce them as one of the first things that I taught in this series, because there's a few things that you may kind of trip up over and some things that you really need to remember. So, without further ado, we will get stuck in and learn a little bit about variables. Okay, so let's just check that this is all running. I'm just going to clear my command and we'll do cargo run. It's compiling and building. There we go. Hello world. So first of all, we know that our code is working. So I'm just going to get rid of this print line because we don't really need it. Now, the first way, and I'll just put this is how you create a variable. So in Python, or many other programming languages, you may be used to just saying, okay, well, x equals 5. And, this assigns x to equal the variable x to 5. Whereas in Rust, you're just going to put let x equals 5. And that's kind of the way that you define variables in Rust. So there we are, we have let x equals 5, and I'll save it and we'll cargo run. Nothing will happen. Okay, we have an error. It's basically just saying it's not an error, it's a warning. And this is something that's quite handy in Rust, is you get these warnings when you run, and it's basically just saying, okay, well, you've got this x here, you've defined this x, but you're not actually using it, so why is it there, kind of thing. So just ignore that warning. But here, here, help if this is intentional, prefix with an underscore x, and it's just telling you how to format your code quite nicely. So that's something that I really like about Rust. So there we go, we've just created a new variable. This is let x equals 5. Now, a couple of things that are worth mentioning, and I'll just comment them down here. I'm trying to get into the habit of commenting in my code, just so that then when, if you've watched my video, then you go back and check, you know exactly what you're doing. So I'm just going to copy a few things down that I've written on my cheat sheet. And, we need to recall that Rust is statically and strongly typed. Now what this means is when you define a variable, Rust will automatically give it a type. This is known as implicit assignment. So what's happening here is, when we say let x equals 5, Rust itself will be able to say, okay, well, you haven't actually specified what the type is, but okay, I know it's an integer, so Rust will just automatically assign this to an integer of some bit. And that's kind of handy. It's similar in Python, you don't actually need to assign them, but it's different to some other programming languages where you do need to define exactly what type it is. So that's a feature of Rust that I thought I would just mention. Now, something that's really worth remembering in Rust is that you can't actually, once you've defined a variable here, so x is 5, and Rust itself has said, okay, well, at the time of compiling, I'm going to just assume, I see that x is storing 5, which is an integer, so therefore the type of x is 5. So I can't then do something like this and say, okay, well, x equals Ellie. If I run this, and then let me just clear this and cargo run, we will come up with an error, and it says expected integer found a string. And what that means is here, Rust has just said, okay, well, we've assigned x to an integer, and down here, Ellie is a string, so we can't do this. So I'm just going to put as a kind of an aside. So we'll put this in comments and just say you cannot do this as Ellie is not an integer. So what this means is you cannot actually, you know, if you start by defining a variable and it's given a number, you then cannot change that type. So here it sees it as an integer, that's the type it is. You then can't change it to something like a boolean or you know, a string. Now, as a bit of an aside, if you wanted to actually specify what type, you know, your variable is, so let's take y and let's assign that to 10. Now, to show what type you want, you will literally just put a colon after your variable and you'll specify what you want. So u32, and if I save this and we do, and I just clear, and if we save this and we do a cargo run again, here we go. Just ignore the warnings. It's just saying that we're not assigning. We haven't used x and y. But yeah, you know, it works. We don't have any errors. So this here, this creates a variable y and assigns a type to it. So this is just an aside. This is how you would actually, you know, assign a type to a variable. Here, this is implicit because I'll call this, we'll say this is implicit, and here we'll call this explicit. The difference being is implicit basically means that the Rust itself is figuring out what this variable, what type this variable is, whereas explicit means we're explicitly stating what type we want it to be. Okay, so those are the two main things, implicit and explicit variable assignment. Now, I realise I didn't explain what U32 means, and we'll be explaining, you know, I'll be getting into all of this in the next section when we go into data types. So the U here stands for unsigned integer, and 32 just means it takes up 32 bits of space. Don't worry if you don't understand what that means, I'll be explaining it in the next section. Okay, cool. So now we have learned how to, I guess, define variables implicitly and explicitly. Let's incorporate it into a print statement, as we kind of always do in coding when we begin learning. Let me just check I've got my semicolons. Yep. So, okay, I'm going to say x is, and then we're just going to put curly brackets. If we remember, this will print out x is, and in here it will put whatever we now write. So let's say x. Okay, if I save that, semicolons in the right place, and we do a clear and just do cargo run. We obviously have the warnings that we previously had, but just ignore them. And again, x is 5. Cool. So let's change this to, in fact, let's copy this and we'll do the same for y. And I'm just going to add some more spaces down here so we can scroll a little bit. Let's do the same for y. Cool, right. Save, cargo run. Hopefully we'll have x and y. Yeah, x is 5, y is 10. Awesome. So that's a way of, you know, creating a variable implicitly and explicitly and then printing them. Now, something that I want to mention is the difference between immutability and mutability. Now, in Rust, any variable that we assign, so, you know, x or y here, they are always immutable, which means we then cannot change them later. So, you know, if I was to just write down here, let's write, you know, x is 10. Yeah, do x is 10, cargo run, we'll come up with an error. Cannot assign twice to a mutable variable. So what that means is we can't do this because by default in Rust, x is immutable. Any variable you assign is immutable. So I'm just going to write that here. Get my comments the right way. So by default in Rust, all variables, and I'll just scroll down a little bit, that are assigned are immutable. This means we cannot change them. So to overcome that, we introduce something called mutability. So what I will do is I'm just going to start by creating a kind of new variable. We'll call it z for the time being. So let z equal 10. Okay, so we've got x and y, and we're saying let z equal 10. And again, if I was to then say, okay, we'll change z to 100, that's not going to work. We've just seen that that comes up with an error because z here is immutable. So how do we make it mutable? Very, very simply, we literally just put a mut in here. And this just means mutable. So let's say creating a mutable variable. Okay, cool. So now if I was to then say, well, I now want the Z to be 99. And I then say, okay, well, let's print Z. So remember the way we print an element, well, a variable in this case, is by doing this. Okay, so in fact what I will do is I'll just copy this twice, because then we can see what happens, and I'll just tidy up the code a bit. I'll keep it all neat and together. So here we create a mutable Z, which equals 10. We're going to print Z, change Z to 99, and then we're going to print Z again. So let me just clear all this so we can see what's going on, and cargo run. Okay, we've got an error. I've forgotten my semicolons, of course. I knew that was going to happen at some point in this series. So let's just clear and go again. Okay, there we go. So x is 5, y is 10, and we have 10 because that is what Z was originally, and then we move it to 99. Awesome. So this is kind of mutability, and I'm just going to put this in capitals just so if you go back and check, then you know this is how we do that. So that's how you change variables. Now another way, so let's just put another way of reassigning variables is you can just put let twice. I mean, it works, but there is a bit of a downfall to it, and I'll explain in a second. So let 10, let's say let's Z, or in fact let's do another one. A is 100, and then let A equal 50, and then we'll just print A. And we'll just do that twice just to show you. Make sure I've got my semicolons in the right place, and I will do a cargo run again. Cool, so we have all this from before, so we have 150, yep, 100 and then 50. So that's another way of reassigning variables, writing let twice. The difficulty is when you then start playing around with different types. So here, we haven't defined what the type of Z or A is. Rust has just seen that Z is assigned to 10 and said, yep, that's an integer. We're going to store that as, I think the default is I32. That could be wrong. I'll put a correction on the screen if it is wrong. And it will, do that. And then again, it will do the same here. And because those two types are the same, it's fine. We can reassign Z to that value. But if I was to put 99.5 and I was to save and run this, just clear cargo run, yep, expected integer. Found floating point number. So what's worth mentioning, and I'll just put a little comment here. So when using mut, the two let's say the variable, in our case Z, you wish to change must be reassigned to the same type. So here, we can't do this because Z here is automatically defined as an integer. You can put let Z and put a little semicolon, a colon, and put U32 like before, and the same thing would happen because this is not a U32. This is I think an F32. Now, don't worry if you don't understand the whole U32s and all that. I'll be explaining it in the next video in a very in-depth sense. So don't worry too much about that. The main the essence that you want to get from this video is that if you're using the mut command, or you hear mut, which means mutable, you cannot reassign a variable that is one type to another type. Now that's really important. However, when it comes to writing let twice, you actually can. And that's just because you're essentially completely getting rid of this previous value here. So let's change it to 50.5, and I will cargo run and see if we get an error. And we don't get an error, and that's because we're not using the mut command. So those are two important things that I wanted to mention. So how you create a variable that is mutable, but also just bearing in mind the type of the kind of variable that you're working with. Okay, so I'll just put down here, I'll say, in fact, I'll put it here just so then I feel like I'm writing my comments all over the place. So I'm just going to put creating a mutable variable. When using mut, the variable Z you wish to change must be reassigned to the same type. And here another way, reassign let twice. I'll put the variable can be reassigned to a different type. Okay, Sorry, I've got loads of exclamation marks everywhere. Okay, cool. So that's kind of one of the main features of variables that I wanted to mention. Another thing is you can assign multiple variables at once, which is always handy because most of the time when you're coding, you're probably not just going to be using the one variable. So, okay, let's do the classic let, and we're going to create a tuple. And I'm going to say, let's think of, let's do name and age again, always easy. And of course, say Ellie, and in fact, I guess let's put name and I guess let's say tall, because I'm not tall, so I'm just going to put a boolean and say false. Yep, I guess that's our tuple. We have a bit of an error here, not sure what it is. It's the semicolon, of course it is. Okay, so we've assigned a tuple here to name and tall, and then you can print. So again, my name is, and I am not. In fact, that won't work. I'll just for the sake of it, just put my name is Ellie. We'll change this back to age just so I can make things a little bit easier. 22, my name is Ellie, and I am. Okay, and then here we just put name and age. Hopefully this should work. I did that quite fast, so I'm just gonna clear and cargo run. Yeah, all good. My name is Ellie and I'm 22. Cool, so here we've assigned more than one variable at once. Again, I could put my hobby. Just put coding, of course it's coding. Coding. So my name is Ellie and I am 22. I love, and then coding. Cool. Now just cargo run again. We have an error. Coding is not found. Aha, because I've put coding and not hobby. That's the variable. Okay. I'm just quickly skimming through this just because it's just adding an extra variable, which I'm sure all of you will hopefully be able to do. Okay, so now we've assigned multiple variables at once. We're going to move on to constants. So this is something that's actually mentioned on the Rust programming language website. There's the website, but this is the document which I've linked down below. And let me just find where it is. So I think it's a variables and mutability. There we go, constants. So I'm just going to quickly read this out just to give you a bit of an overview of what constants are. So like immutable variables, constants are values that are bound to a name and are not allowed to change, but there are a few differences between constants and variables. Firstly, you're not allowed to use mut with constants. Then they're just immutable by default, so they're always immutable. So we can't, you can't change that. That's just something that's kind of given. You just have to say, okay, well, constants are given. You declare them using the const keyword, and okay, cool. So if you're a little bit more interested, you can have a read of this page, but I'll just dive in, and we'll type in constants. I'm putting capital. It's not letting me do capital letters. Constants. I'm going to stop with the exclamation marks because I'm getting a bit carried away. Okay, so we're just going to do let, as usual, const. Now I'm going to use an example that I found online, just basic, is let's use ID. So ID is going to be our constant, and we're going to define it as an i32, which is an integer of 32 bits. Don't worry if you don't know what that means, I'll explain it all in the next section. So we've got the i32, and we're just going to make this equal, I guess, 001. So that's some form of ID. And then we're just going to print this out. So as usual, do the usual, and ID. So that's our constant. Okay, so let's save this, and let's clear, cargo run. Okay, we have an error. Let's have a look. What's the error? It's because I've put let instead of const. Let's save, cargo run again. Awesome, there we go. So it's come out with 1. Apologies. Ignore what I said before. There's no let there, just const. And that's because I just got a little bit tripped up when I saw here it said const keyword instead of the let. I thought it said with the let. I just got a little bit tripped up there. So constants are defined using const, then the name that you want. So let's say you wanted it as, say seconds. And so it says 1 second, I guess. And we change this to seconds. just going to put my semicolon there before I forget. Cargo run, there we go, 1 also works. That's how we define constants. Now, obviously, if I was to then say, well, all right, well, let's change seconds to equal 0.2. And, you know, you may guess, if we cargo run, we have an error, because we cannot assign this to that expression, and that's just because we're working with a constant here. So I'll just put here in comments. So a constant is immutable. It cannot be changed. And we cannot use the mut command here. Once it's there, it can't be changed. Alright, so that's constants. That's just a brief overview of constants. I guess constants are handy if you do genuinely just have a, you know, I guess a number or something that just doesn't change at all and you want to use it. So, you know, it's a variable that you don't want to change whatsoever throughout your code. Now I'm going to move on to something called shadowing, and this is also mentioned in the online document here, and I'll explain what's going on through some code. So first we're just going to set up a little scenario. Okay, so we're working our way through the alphabet, so we're on B, I think, for for constants. So let B equal, let's say 3, and again we'll just print line. We'll do the same. I could just copy this, making life hard for myself. Okay, and as we expect, if I was to run this, it's just gonna run print 3, which it does. Awesome. Now, what I can actually do with, you know, this ties in with shadowing, is I can create a new scope. Now, you don't have to worry too much about what scope means, but here you see in the function main you have these 2 curly brackets that enclose everything. So everything inside these 2 curly brackets will run. You can actually make your own curly brackets, and this is what is known as a scope. So I'll just put here, in fact I'll indent it and say are known as scopes. Now this is not to be confused with this, you know, this here. This is just generally talking about the whole section on its own. Okay, so let's create a new scope, and inside this scope we're going to redefine B. So first of all we need to make sure that B is mutable, to make sure that we can, you know, change B. I'm going to say let B, in fact we don't need the let, I'm going to say B equals 4, and inside here I'm going to print ln, and we're just going to do the same. In fact I'm just going to copy this just for ease. Okay, so we've got this mutable variable B, we print it, we've created our new scope, which I'll just put there. Redefine B, we then print B. Now what I'm going to do on the outside of this scope is I'm going to say, okay, well let's let B equal B plus 100. Okay, and then we're going to print B again. Now you can pause the video, and just before I run it, I'm just going to not forget that we need a let B in here because we are redefining what B is, and I'm just going to bring this over. I'm not sure how, I think my formatting is a little bit wrong here, but the code will run regardless. We'll go on to a clear terminal and just type cargo run. Okay, so we have 3, 4, 103. So notice what's happened. It's printed 3. It's then, why is there a C there? Not quite sure why there's a C. It's then printed 4. And then here it's taken B equals B that we've defined before plus 100. Now you may think, oh, well, we redefined B here, so it must be 104. But actually what it's done is it's skipped over this and it's added the original B that we had. Now you may be wondering, you know, why that is. Essentially what happens is if you create your own scope, anything you do inside this scope does not affect the outer scope. So, you know, all this here is known as the outer scope. This here is the inner scope. So I could change this to, you know, that big of a value, cargo run it, doesn't affect it. And that's something that's quite nice in Rust, is that you can just have your own scopes. You can do a little bit of, you know, manipulation of things in your own scopes, and it won't affect the overall outer scope. Something that I thought was really worth mentioning in this video. It's just really, really nice, and I guess I'll put that in some comments. So let's say you can use B from the exterior scope in the interior scope without affecting the value of B in the exterior scope. Now I realise that's a lot of exteriors, interiors and scopes, but hopefully that makes sense. So that's everything that I wanted to talk to you about in terms of variables. So we have implicit and explicit assignment of variables. We have mutable versus immutable. We have constants, and we also have shadowing. And hopefully that will give you a good overview of variables in Rust. So that has been the video today. I hope you enjoyed it. Please give the video a big thumbs up, comment down below, subscribe to the channel as well. There is also a Patreon that I've set up and a donation page if you fancy checking those out. The links will be in the description. Thank you so much for watching, and I'll see you in the next one.